Hello, my name is Conner Hicks, and this is Grassroots EV Motorcycle Kit. The purpose of my project is to turn forgotten materials such as older motorcycles into functioning forms of transportation while also solving a crisis involving budget as well as the environment. Comparable EVs on the market include the Tesla Model 3 at $40,000 and the Harley-Davidson Livewire at $30,000. My budget goal, on the other hand, is merely $1,400. So, on to the build. My build starts with a virtual recreation of my motorcycle frame, which involves recreating it in SolidWorks. Here we see the frame and the beginnings of my battery tray. We put them together, and we see that we can use old mounts and continue to grow using the old motorcycle platform. Eventually, we will move on to the motorcycle motor mount, which sits under the seat, and eventually we can mock up the real-world motor that we will be using in the project. Here we can see how the underside of the mount attaches to the motorcycle frame. The motor we will be using is a 15 kilowatt permanent magnet DC motor capable of 150 amps continuous and a peak of 300 amps. Electric motors behave differently than internal combustion motors, but we can expect around 18 horsepower from this motor. Now that the virtual work is finished, we can begin on the physical work. The first of which involved removing all the old mounting tabs and hardware left on our old motorcycle. The second part involved making our precision cuts and drilling in order to retrofit and begin fabrication of our custom mounts. The first of which is our battery tray, and the second of which is our motor mount. Both the motor mount and the battery tray both use recycled forms of steel angle iron and flats. The sprocket system utilizes a standard 14-tooth sprocket and a custom CNC milled sprocket with 72 teeth in the rear. The final step is the wiring, which I'll discuss further in just one moment. Now that everything's pieced together, we're ready for a quick test drive. The first test seen here was ultimately a failure, as we had yet to tune the computer and had also not properly tightened the chain. So after that first failure, it was back to the computer. Let's take a look at the wiring. The main system features a negative ground and a positive line into a 400 amp fuse and eventually into a 48 volt contactor. This contactor works by only allowing the system to operate if 48 volts is supplied. This is a recycled unit off an old forklift. The computer is set up as follows. There is the main 48 volt positive in, the motor out, the throttle input, and a 48 volt system ground. After multiple changes to the throttle input curve, as well as setting the bike acceleration to no more than 40%, we see here a successful test in which we're able to ride the bike around the block without crashing. A few minor cosmetic upgrades later, and we're left with a finished product. But at this point, I bet you're all wondering, well, does it work? Or rather, is it practical? Well, first we wire our 12-volt batteries in a series. There's a total of 4 batteries. At the end, you should be left with 2 leads, a negative lead and a positive lead. Once those are connected, a simple twist of the key and a loud thump later, and the bike is ready to ride. With 4 fully charged batteries, I was ready to begin the first test. The first test is range. In order to accurately calculate the range, I rode the bike from full charge to 0 in a relatively calm portion of where I live. I chose a speed of roughly 25 to 30 miles per hour in order to keep the motor under constant load. This would give me a more conservative range estimate. My goal range was calculated as so. We should get around 32 miles out of our system. Unfortunately, I was only able to reach 20 miles during the test. The acceleration test resulted in roughly a 1.7 second 0 to 30 time, which is a stark improvement over the stock bike, which would have been around 4 seconds. Braking from 30 miles per hour seemed to be comparable to the standard bike's time. The final test is maneuverability. Although hard to quantify, I determined that through feel, this bike feels much better than those that I've ridden in the past. Ultimately, I was able to meet or exceed 3 out of my 4 metrics. My goal budget for the bike is $1,400. In the end, I'd spent roughly $1,722 total. Although I exceeded my budget, I feel that the extra $300 was well spent as the bike is so usable. In order to improve the bike, you'd have to make the jump to lithium-ion, as well as replace components that are causing friction problems. This would dramatically increase your budget. This concludes my report. Thank you for watching.